Hey y'all, so I had a request to talk through a couple of the problems on Study Guide Part B, so I figured I'd go ahead and record it for everyone and then post it for anyone else who wants to see some of these worked through. The problems I'm going to be looking at are number 3 here, and then 7, 8, 9, 10, 11, 12, so pretty much this whole second page. And then we'll take a look at the challenge problems as well. Alright, so starting with number 3, it says write the quadratic equation below in standard form. So looking at this, it's in vertex form right now. Standard form, we would want to get it to look like this. ax squared plus bx plus c. So basically what we need to do here is just multiply everything out. So take a little time to just simplify this equation. Alright, so we have x minus 3 squared. So that means x minus 3 times itself. I'm going to rewrite this. X minus 3 times itself, times x minus 3. Alright, then we got a plus 5 on the end. Okay, so how do I deal with this parentheses times parentheses? Well, I'm going to distribute, and we're going to do FOIL. So first terms times outside terms times inside terms times last terms. So we just distribute both terms across the parentheses. When we do that, we get x times x is x squared. X times negative 3 is minus 3x. Inside terms, we have negative 3 times x again, so minus 3x again. And then we have negative 3 times negative 3, which is positive 9. And we still have that plus 5 hanging out on the end. So we're almost into standard form. We just need to simplify. So I'm going to keep my x squared out front. Then I got negative 3x minus 3 more x's, so that's negative 6x. And then I've got 9 and 5, which makes 14. So we've gotten to standard form. Again, the tricky part here is to take this squared, x minus 3 squared. That means x minus 3 times itself. Okay, so moving on to number 7 here. We want to solve this by factoring. So right away I notice this is kind of weird because I don't have a c term. I don't have a constant. So instead what I want to do is look at my two terms and ask, what do they have in common? So I see that they both have an x. So what I'm going to do is I'm going to undistribute or factor out everything I can. I know I can take an x out of the parentheses because both terms have an x. I also notice that 12 and 20 can both be divided by 2 or even better yet 4. Both of these numbers have a greatest common factor of 4. Alright, so if I take 4x out of the equation, what's left over? Well, we'd have 3x here. This 4x times 3x would be 12x squared. And then we have negative 5 here. Because 4x times negative 5 would get us back to negative 20x. So basically what we're doing is dividing out a 4x. Okay, so if we do that, now we're in factored form, so we can solve our two pieces. 4x could be 0, or 3x minus 5 could be 0. So even though this looks a little bit different, we still treat it the same way using that zero product property. So 4 times something is 0, something's got to be 0. Over here, we should solve this out. So if I add 5 to both sides, I get 3x is 5. Divide by 3, and I get x is 5 over 3. And we can check against the study guide and make sure that's correct. So as you're working through the study guide, remember you do have solutions. So we can see right there, x is equal to 0, 5/3. All right, let's try number 8. So number 8, again, I'm trying to factor this here. But right away, I noticed that I've got stuff on both sides of the equation. We know it has to be equal to 0 in order for us to break it apart and solve. So I'm going to subtract 2x squared from both sides of the equation. All right, so we got 0 on the left now. And over here I've got x squared minus 2x squared, so that's negative x squared. And then I still got my positive 36. Okay, so this one's a little bit different. This is a special type of problem called a difference of two perfect squares. And it's hard to see that at first, but I have this negative in front of the x squared. So if I take that out, basically I'm taking out a negative 1, I end up with x squared minus 36. And that's a difference of two squares, which is a special type of quadratic, which we'll talk about later. But we can actually factor this just like we always do. So if I think through it, I need to multiply to get negative 36, and I need to add up to 0. So it might not be super clear why, but if I think about this, again, I'm kind of ignoring that negative 1 for right now, but I can think of this as x squared plus 0 x's, because we don't have any x's, minus 36. So you can see I need to multiply to get c, negative 36. I need to add up to b, which is 0 in this case. That's telling me that my two factors are actually going to be the same number, but opposites. So 6 times 6 is negative 36. And if one of those is a negative, then we get 6 minus 6 is 0. Cool. So this is actually going to break down with two very similar factors, one positive, one negative. That's pretty tricky. X minus 6, x plus 6. We'll see a lot of these difference of two squares throughout the year. Sometimes we call them dots, difference of two squares. But you'll start to recognize them. If I just have an x squared minus a perfect square like this, then it's going to break apart the same way every time. Sweet. So again, we can use our zero product property. X minus 6 might be 0. So that means x would be positive 6. Or x plus 6 is 0, which makes x negative 6. All right, moving on to number 9. This one we want to solve by factoring, but the problem is it's already factored, except there's a 42 here. So even though this looks like it's going to be easy because it's already looks like a factored form, it's not, because it's not equal to 0. So we're going to have to multiply all this out and then put the 42 into it and then refactor it. So this is going to be a little bit of work, but shouldn't be too hard as long as we're very careful. So again, we need to multiply this out so that we can incorporate the 42. We get x squared. All right, we get x squared minus 2x plus 9x minus 18. That's all equal to 42. All right, so we said that we have to have everything off to one side so that one side is just equal to 0. So I'm going to subtract 42 from both sides. All right, so now we have the 0 on the right side like we wanted. And let's see what's left on the left. Got x squared. 9 minus 2 is 7x's. And then 42 and 18, they're both negative, so we get negative 60. Yeah. All right, so now I got to factor this down, right? Now that we're equal to 0, now we can go through the factoring process and break this back down into two pieces multiplied together. So I know I'm going to have x times x. And then I got to find something that multiplies to get 60, negative 60, and at the same time adds up to 7. Let's see. Thinking through my factors of 60, you might have to kind of type them all out or write them all out, think about it. But something just came to mind. What about 5 times 12? 5 times 12 makes 60 and has a difference of 7. So I think that's going to work for me. 12 and 5. 12 times 5 is 60, but I'm going to need one of them to be negative. If I'm trying to get positive 7, then I want the 5 to be negative. So x plus 12, x minus 5. So there's our answers, negative 12 and positive 5. Cool. Again, you have access to the answers on here, so you can see that's correct, negative 12 and 5. Okay, number 10 is just asking which equations have roots of negative 5 and 2. So there's a couple ways you could do it. You could factor each one, break this down, and see, okay, this is x, and 5 and 2. Get 3, you need to be positive 5 and negative 2. Right, we can do it that way, and actually that's the right answer. Another way to do it would be to plug stuff in. I could plug in 2 into each of these equations and see which one comes out to be 0. Sweet. So we're not going to dive too deep into that one so that we have time to look at this. All right. You will have word problems on the test, so I'm trying to get you prepared for those with this kind of thing. So it says the height of an arrow shot into the air can be represented by the equation negative 16t squared plus 110t plus 6 is equal to h. T is time in seconds, h is height in feet. So the first question says, what is the maximum height of the arrow? So we have two different approaches here. We could throw this into the graph and use Desmos to help us solve, but we could also solve this with algebra. But we're going to use Desmos here. We'll talk about how we would get through it with algebra, but just for the sake of analysis, because the next one's going to be tough, let's take a look. All right, so we have in the problem here, it says h equals negative 16t squared. Desmos isn't going to really like that, so I'm going to say h of t, just so that Desmos understands what's going on here. Negative 16t squared plus 110t plus 6. All right, so Desmos will understand this. If I just said h, no, it gets it. It figures it out. Desmos can be a little weird sometimes when you're using different variables other than y and x. So you can always just kind of convert this back to x's if you want and y's, just to be Desmos friendly. But it looks like it understands what's going on here. Oh no. All right. Don't want to mix variables. Okay, so this is the path of our arrow, and this is really hard to read because we're not in the air very long, only about 7 seconds, but we're going very, very high. So what I'm going to do is adjust my graph just a little bit, and this isn't necessarily a step you have to do, but I'm going to go ahead and do it just so that I can understand what's going on. Oh, that's already so much better. So you can see that it makes sense to have our x-axis pretty small, going from 0 to 7 when we come back to the ground. And the y-axis goes really high, up to about 200. Okay, so the first question was, what is the maximum height of the arrow? So what we can do to solve this is, again, we're using Desmos here, and Desmos is automatically going to show you your vertex, which is so, so useful. Anyway, so our vertex is at 195.063, so 195 feet. 195.063 feet. So again, you are going to have some word problems, and what I expect from you is to be able to throw the function into Desmos and use Desmos as a way to analyze the situation. You can of course do this algebraically as well. So you can see I plugged in t equals negative 110 over 2 times 16. So the reason I did that, we talked about this briefly in class, but since we're using technology so much this year, I haven't really been emphasizing these skills as much. But we said that you can always find your axis of symmetry. Remember, that's the line that cuts your parabola in half. We can always find the axis of symmetry with this equation. X equals negative b over 2a. So that's what I've done on the study guide answers. Negative b is the number in front of the plain variable, over 2 times a. A is the number in front of the squared variable. So what that gives me is the axis of symmetry, which happens to be the very middle of our graph, which tells us where the vertex is. So notice when I did negative b over 2a, it spit out 3.44. That's how many seconds it takes for the arrow to get to the vertex. So then I can take that and plug it into the equation. So I can find what is h of 3.44. Right? What does the equation give us when we plug in 3.44? And it shows us the height, right? 195 and some change. Notice it's a little off because we rounded 3.43 to 3.44, but it's essentially correct. Sweet. So I know this might be a little confusing because we didn't do something like this in class, but we did talk about that axis of symmetry equation, which is where this is coming from. Okay, number 12 is a little bit harder. It says, how long did it take for the arrow to reach the ground? So again, on the answers, I'm showing you how to use the quadratic formula to solve this, but you can use Desmos or use completing the square to solve this as well. So what we're looking for is the root. So we shoot the arrow at about 0 seconds, goes all the way up, comes back down after 6.92 seconds. So again, if you're using Desmos, as long as you understand what's being represented by the graph, you should be able to answer this pretty easily. And that is the right answer, 6.93 seconds. So just so you know what's going on, here I use the quadratic formula to solve. Again, something we haven't really emphasized in this class for the sake of time, but it is pretty useful. The quadratic formula allows us to always solve a quadratic, and it does so with this equation. Negative b plus or minus the root b squared minus 4ac all over 2a. And again, a, b, and c are the numbers here in standard form, a, b, and c there. So we didn't do this, but another way to solve this would be by completing the square. So I did show you another method that can always find your roots. So we could take this and complete the square, right, like you practice on 1.6.3. But again, I'm happy with you doing Desmos for word problems to help you with that kind of analysis, especially when the roots are real ugly like this one. Cool beans. So it took 6.93 seconds. All right, last thing I want to look at is, well, there's a couple more. So the last page of the study guide is some challenge problems. So we didn't do anything like this in class really, but it's really useful to go to that next level and see if we can still analyze, especially if we're focusing less on the algebra and more on the skills of analysis and using the graph. So it says that Rachel and Amber throw their books off the roof, and you have these two equations. It says, how many seconds did Rachel's book hit the ground before Amber's book? So again, we could use algebra to solve. You'll see on the solutions that I again use the quadratic formula to find how long it took for those to hit the ground. But we can use Desmos to do that as well. So let me type these in real quick. So you might notice that all of these equations have the same a value, negative 16t squared. And there's a reason for that. That's the speed of gravity in feet per second squared. So these are accurate-ish equations according to the laws of physics. Okay, so get those into the graph. Double check them. Okay. So we got Rachel is the red graph, Amber is the purple graph. So you can see that Rachel's book hits the ground at 4.48 seconds, and the other person's book hits the ground at 5.09 seconds. The question asked, how many seconds did Rachel's textbook beat Amber's to the ground? So how much faster was it? So 4.48 versus 5.09. We just have to find the difference between those. How many seconds between when one person's book hit the ground to the other one. So you can see those same values that I found algebraically here. So we just subtract 5.09 minus 4.48. So Rachel's book hit the ground about 0.6 seconds before Amber's book. All right, cool. Looks like Amber launched hers with more velocity. Okay, so another word problem where you can solve it algebraically, but what I'm really expecting from you is to use Desmos to solve. All right, last one here, which again, we didn't really see this type of problem explicitly, but we did see a lot like it, and you should be able to kind of piece things together. Right? We worked with quadratics, we worked with inequalities. Now, can we piece those ideas together? Right? Because even quadratic can be represented as an inequality. Okay, so first things first here is I want to graph this quadratic. So I got x squared plus 2x plus 1. Let me see if I can factor it. So 1 times 1 gives me 1, and if I add those together, I get 2. So I know I have a single root at -1, Right, x equals -1 is my solution here. I know I have a single root right here. I also know that I have a y-intercept at 1. Right, if I plug in what is f of 0, I just get the constant on the end. All right, I also know it's a positive. Right, we have a positive number in front of x squared, just a positive 1. So I already know what the shape of this graph is going to look like. It's going to be something like this. Now, we didn't do a lot of graphing by hand, just because we're limited in that capacity. We could also use Desmos to help us graph this. So what I got to figure out now, so we have our equation, and maybe I want to be a little more exact. So I have a few points, -1, 0, 0, 1. I got -2, 0. Sorry, -2, 1. Really, they should be in order, but I don't care. All right, what happens if I plug in 1? If I plug in 1, I get 1 squared plus 2 plus 1. So 1 plus 2 plus 1 is 4. So just to add a few more points on my graph. There we go. Okay, instead of calculating -3, I'm just going to use symmetry, because I know I have a line of symmetry right here. So I know I'm going to have a point right. All right. So let me just extend this here. Try better. All right, at any rate, we have it graphed now. So now I got to figure out, because anytime we have an inequality, I'm either going to shade on one side of the line or the other side of the line, or on the other side. So I got to figure out which way am I shading. Now, when we worked with lines, we had a really simple rule for this, right? Y is greater than above the line. Y is less than below the line. With parabolas, it gets a little bit more tricky. But what you should do is you should use a test point. Okay? So I'm going to pick a random point on the graph, and I'm going to try to pick something that's going to be easy to plug in. Right? So I don't want to pick like 9, -9, because I'm going to have to plug that in and calculate it. That's not fun. So what I'm going to do is I'm going to pick a pretty easy point right here. This point, 1, 0. Okay? I have a test point. 1, 0. So x is 1, y is 0. So my question is that point a solution to the inequality? So I'm going to plug these in, and if I get a true statement, then I know that this point is in the shade. If I get a false statement, then I know the other side of the parabola is the shade. So let's try it. Let's plug it in. So 0 for y, greater than 1 squared times plus 2 times 1 plus 1. Okay, so I get 1 squared is 1 plus 2 plus 1 is 4. So I get 0 is greater than 4. 0 is not greater than 4. That tells me that this point right here is not part of the solution set. It means the solution is the other side of the parabola. We're going to shade on the inside. Now there's one other detail which I've forgotten here. Remember when we're graphing inequalities, we either have a solid line or a dashed line. Here I've drawn a solid line, but that's incorrect. Notice I have y is greater than. So I'm going to go back and try to fix this with an eraser. It's probably not going to work very well, but I should have a dashed line here. Why is this so very small? All right, so my quadratic line should be dashed. This is not the proper way to do this, but it's going to work. Okay, so it should be a dashed line with shading inside the parabola. So again, we can use the answer sheet to check that. Notice I have a dotted line, and I'm shading inside the parabola. Also, a good thing to note is that Desmos can do this. Desmos should be able to handle this. So let's see if I can just plug this one into Desmos and get my answer here. Y greater than -x squared minus 6x plus 4. So y is greater than or equal to, again, -x squared minus x squared minus 6x times 4. Okay, notice my scale is really weird because I messed with it earlier for that other problem. So I'm going to fix that real quick. -10 to 10, both axes, something back to normal. Okay, cool. So we see we've got our parabola, and the shading is on the outside. And notice here we have a solid line because it's greater than or equal to. Cool. So these challenge problems are just to get you thinking on a little bit of a higher level, connecting the dots for those pieces those things that we learned kind of separately and seeing how those can come together. Cool. So don't stress too much about challenge problems. You will have some kind of tough challenge word problems thrown at you on the test, but remember to use Desmos, right? I want you using that tool to help you analyze your graphs. All right, thanks. I hope this kind of clears some of that stuff up. Bye, guys.